Welcome back. Example 3. Again, our goal is to solve for x. So all we're doing, we're going to make one side of our equation 0, which guess what? It already equals 0. So we already have our first step done. Yes. After that, we're going to factor this thing and then set every single factor equal to 0 and solve for x. And that's all we're going to do. So let's get started. Okay, so since this side already equals 0, now my goal is to factor which? What is the factoring technique we always try first before we try any other factoring technique? That would be to find the GCF. So let's see if this problem has a GCF. I don't know. Let's see, what is the largest number that will divide into 6 and 4? That would be a 2. And then both of my terms do contain an x. So that means I can include an x in my GCF. Do you guys remember what exponent do we use when we use a variable with an exponent when we're trying to come up with GCF? Which exponent do I use? You do use the smallest exponent, which I have an x squared and I have an x to the first. So the smallest exponent is x to the first, or 2x to the first, or 2x. Whatever floats your boat. Okay, then I'm going to write GCF in the very front. And I'm going to divide each of these bad boys by 2x. And I'm going to put the first power just because it helps me when I divide variables with exponents. Okay? All right, so let's see here. 6 divided by 2, that's going to give me a 3. And then x squared divided by x, well, I'm going to subtract the exponent. So 2 minus 1 gives me x to the first. So 3x or 3x to the first. However you want to write that. And then 4 divided by 2 gives me a positive 2. And x divided by x will cancel and turn to 1. So I'm not going to write it. Okay, so right now, usually after you factor out the GCF, you look inside of your parenthesis. I can't say that today. You look inside the parenthesis and you ask yourself, can I keep factoring? Well, I only have 2 terms. And the only technique we about with 2 terms is the difference of squares, which I don't have a difference. Difference means to subtract, and I cannot square root 3x and 2. So guess what, you guys? We have factored till we cannot factor anymore, which means this right here is our factored form. We have reached factored form at this point. So factored form. Okay, so after you reach factored form, we have something times something equals 0. So at least one of these 2 factors has to be 0 for this to work out. So we're going to set each factor equal to 0, which factors are numbers that multiply. So we're multiplying 2x to the 3x plus 2. So I'm going to set 2x equal to 0, and I'm going to set 3x plus 2 equal to 0. Okay, so you set every single factor equal to 0. And then all we have to do from here, you guys, is solve for x. So let's get started. Okay, so I need to solve for this x, which secretly they're multiplying. Okay, so the way I bring 2 over is by dividing 2 on both sides. So 2 divided by 2 will cancel and turn to 1. 0 divided by 2 is 0. So one of my answers is x is 0. So remember, our answers when we're solving for x in a polynomial are called zeros, roots, x-intercepts, or solutions. So one of them is x equals 0. Or we have another possibility that could work. All right, let's solve this thing for x. So I'm going to move my 2 to the other side. So the way I bring positive 2 over, I'm going to subtract that thing on both sides, which 2 minus 2 will cancel and turn to 0. 0 minus 2 is negative 2. So I'm left with 3x equals negative 2. Okay, and then the way that we bring the 3 to the other side, well, these 2 are secretly multiplying. So the way you bring 3 over is by dividing by 3 on both sides, which 3 divided by 3 will cancel and turn to 1. So I'm left with x equals negative 2/3. Okay, so these are my 2 possibilities that if you were to substitute your x back in would make this thing equal 0. So x can be 0 or x can equal negative 2/3. And we have solved for x, which means we have found the zeros, roots, x-intercepts, or solutions to our polynomial. Excellent job.